Hello everyone, welcome to POC TV. Today we are going to see Python Pandas chart visualization. The objective of this proof of concept is to understand more techniques for chart visualization. In the last session, we have seen a few bunch of bar plots, histograms. Today we are going to see more techniques in plotting, like area plot, stacked, area plot, unstacked, scatter plot, single color, scatter plot, multicolor, scatter plot, black and white, legend, and scatter plot, color legend, and finally scatter plot, bubble sizing. To start with, we'll be seeing what libraries we need to load and then some terminologies. We need to import matplotlib python plot as plt. In the Python libraries, there is a matplot libraries is there. So you need to import those libraries. And then we are importing pandas as PA and importing numpy as NP. Those are the libraries we need to import. And in terms of terminologies, we have seen bunch in the past few sessions. Today we will be talking about CMap. CMap is basically a color map instance in matplot library. Let's move to our new plotting mechanisms. Area plot. So in terms of area plot stacked, you are using a variable datf and then pandas dot data frame of numpy. I'm using a random function, say 10,4 matrix, and columns. I'm passing the columns which I have used in the past: blue, orange, green, and red. And I'm using the variable dot plot area function to plot this. So if I exit this, then run it, you can see the blue, orange, green, red is in a stacked fashion for the area. The whole area is being plotted. To understand this random function, you could see now it is being plotted with some random numbers. If you rerun this again, you can see it's plotting in different positions. Basically, every time it uses some random values to be plotted. So you will see different combinations in each time. Next, area plot unstacked. I'm using the variable datf dot plot area of function, and I see stacked equal to false. It is actually exactly the same one what we have used in the past one, but I'm just plotting the area with stacked equal to false. I'm exiting this, running. You can see the area is plotted, but it in a stacked fashion. Here you can see these are like separate solid colors. Here you can see is like one on the top, like overlapped. And if I keep doing, this stays as it is because it is actually using the last random value generated by this is being applied for this. So this never changes. If you run this particular random function again, which makes it a little bit different area plot, now you will see the same difference here. So exactly what it is. Next, scatter plot single color. I'm using the data variable pandas dot data frame of numpy dot random function. I'm passing 100,4 matrix using the existing columns blue, orange, green, and red. using the variable of species. It can be anything. I am using a species of flowers. Say PA dot categorial. I say rosa into 40, lilium into 40, and tulipa to 20. In general, these are like a flower species. Rosa is rose, lilium is lily, and tulipa is tulips. So say datf variable dot plot scatter off using a blue and orange to be scattered. So exit this and run it. You can see this is scattered now, where you can change the random function into a little bit bigger. Say I'm saying 100 into 1000, and then I also pass 1000 combination here. So I make 40 into 400, then it's 40 into 400, and this into 200. So this sums up with 1000. So if I run this again, you can see this is too dense because of this combination, so dense population. Blue on the x-axis and orange on the y-axis, you can see. Next, scatter plot multicolor. So I'm using the same scatter plotting, but I'm using different colors to make it more visible and generic, rather than same colors does not make a big visibility. I'm using a new variable ax datf variable dot plot scatter off function, and in the x-axis I'm saying blue, and y-axis I'm saying orange, and color equal to I'm saying dark red, and label say team1 this color, like a red color. And then again I'm using a datf variable dot plot scatter off function, passing the remaining x-axis green and y-axis red, color equal to dark green, I say, and label equal to team2. Then I say, okay, ax equal to ax. So if I exit this, then run it, you will see this is pretty dense graph. You can see team1 is red and team2 is green. This dense is because of it is taking the value from the previous output. So here I'm putting back to 100, then 40, 40, then 20. So run this. This random function generates some scatter plotting. So the same value is being utilized in this input. So now you can see a little bit reasonable. Team 1 is represented as red and team 2 is represented as green. You can define anything in the labels as you wish. The x-axis is plotted as green, y-axis is plotted as red. Next, scatter plot black and white legend. In the past, we were using the legends inside the graph itself. It's not so visible. In the first one, you see there is no legends here. In the second plotter, you can see there is some legend, but it is inside the graph, which is hiding some of the plotting area. So to make it more visible, so say, scatter plot black and white legend. So make the legend outside the actual plotting area as a separate vertical bar, where you can say, okay, if it is 0.8, it is dark black, and then a little gray, and then lighter gray, and too light. So that's how it is plotted. So I say datf variable that plot scatterer function, pass b, o, and then c, size equal to 25. S is basically a size. So if I exit this, then run it, you can see it is plotted. If I change this 25 to 50, you can see the size difference. You see the the dots are actually a little bit bigger. If I say 100, be much bigger. So exactly it looks like. And then this black and white is not like a too clear where you cannot differentiate widely, where dark black to light black and then gray and then white. So it's almost, the white is invisible here because it's already merged with the background. So if you are just segregating two colors, it's kind of okay, assuming if the background is dark. But to make more visible and then clear mechanism, you can use a color legend. So using the same function, variable datif dot plot or scatter of function, x-axis to b and y-axis equal to o, and c I say species, and c map, it's basically a color map we are utilizing. So viridis is the default color map in Python matplotlib library. So where this is basically in Italian, um, this is called green, freshness, all that you can see. And size, I'm saying 25. So if I exit this and run it, so you can see it is plotted. Tulipa is plotted as yellow, and then Rosa plotted as green, and Lilium is, black or dark blue or something. So now you can see the species is actually vertically aligned with a legend, clear legend. It is exactly plotted the x and y axis. So by this way, you can make it so clear. So whether this is one of the default CMAP, but if you want to use something different, you can type RDPU, where you can see a little bit different color, a little bit purple, dark pink, and then mild pink. So if I say 25 size to 50, I can actually see a little bit bigger colors here. So that's exactly how you can make it more visible. So next, scatter plot bubble sizing. It's the same scatter plotting, but I'm using a little bit of different bubble sizing for different categories. I'm using the variable datf dot plot scatter of function, x-axis equal to blue, y-axis equal to orange. I see from my above definitions. And s equal to, I'm saying the variable of, see, g, and then into 100. So if I exit this and then run it, you can see the bubble is a little bit different. There are big bubble and then a little bit smaller and much smaller. To summarize, we have seen bunch of plotting mechanisms. These are little more additional um, visualization techniques. We have seen area plot stacked, area plot unstacked, scatter plot single color, scatter plot multicolor, scatter plot black and white legend, and scatter plot color legend, and scatter plot bubble sizing. I hope you enjoyed watching today's session. Thank you.